YouTube channel. You can see in my. So beta this topic in the P block element of 15 group element. In my previous class, I completed up to I completed the compound of the nitrogen, that is a ammonia. And now I want to start with another compound of nitrogen, that one is nitric acid. But this is a topic was given in your NCERT as a HNO3. We have to talk about the lab method of preparation and commercial method of preparation of nitric acid. How the nitric acid can be prepared in lab, as well as how the nitric acid can be prepared commercially. But a lab method is very simple. Just by heating a potassium nitrate or sodium nitrate with a sulfuric acid. Let us say it is a lab method of preparation of nitric acid. What is that? Let NaNO3 or KNO3. But when it is heated with a sulfuric acid, H2SO4, in presence of sulfuric acid, what it can form? It has a tendency to form the bisulfate, means I will get as a NaHSO4, but one H and NO3 will form the nitric acid. It is a lab method to prepare the nitric acid. HNO3 we got here, right? But if you want to prepare this HNO3 in a large scale, to large scale called as a what? Commercial method of preparation. Commercial method of preparation of nitric acid. But it can be done by the method called as Ostwald process. Right? With the help of the Ostwald process, we are able to prepare HNO3. How better with the help of Ostwald process we are able to prepare HNO3? So we should know what are the reagents are there and how the stepwise reaction we have to perform for the preparation of nitric acid. 1 second. Just I'll fill the ink in my pen and I'll tell you. Now, but a commercial method is a method to prepare the Ostwald process is a method to prepare the nitric acid. For that one, the first step, oxidation of ammonia. But oxidation of ammonia, oxidation of ammonia, oxidation of ammonia can be done in presence of a platinum or rhodium as a catalyst. Right, beta? PT or RH as a catalyst at a temperature of 500 degrees centigrade. And pressure should be, sorry, beta, at a temperature of 500 Kelvin and the 9 bar of the pressure. Oxidation of ammonia will give rise to NO, oxide of nitrogen, by the liberation of the vapors of water. Right? If you want, you can balance it, beta. 45 and 46. Simple way to buy it. How simple, na beta? 45, 46. 4 nitrogen, 4 nitrogen. 12 hydrogen, 12 hydrogen. 6 plus 4, 10, 10 oxygen. Balance. We got? Right. But a nitric oxide, which one we got? It further undergoes oxidation and it will form nitrogen dioxide. But make it 2, oxygen 4, make it, sorry, 4 means 2 plus 2, 4, balance. We got it here? But as we got to nitrogen dioxide, this nitrogen dioxide should be dissolved in the water to give the HNO3. See here, this NO2, which one we got, must be dissolved into the water. But as soon as this dioxide of nitrogen get dissolved in the water, that means it undergoes hydrolysis and it form here as a HNO3 and vapors of NO. It form HNO3 and form the vapors of NO. But obtained vapors of NO again recycled to undergoes oxidation to give NO2. NO2 and hydrolysis gives rise to HNO3 and NO. Balance it better by putting 3 here. Then NO will be HNO3. Hydrogen how many beta? 2. Make it 2. Nitrogen 3 means 2 plus 1 3. Oxygen 6 plus 1 7. Everything was balanced. We got the nitric acid. So beta, these are the 3 steps are there to prepare the nitric acid by the Ostwald process. Right? Chalo, take a note of this one or take a screenshot. But this obtained nitric acid on distillation, it forms 68% of nitric acid. But again, further concentration can be done by adding sulfuric acid and make it as a 98% pure nitric acid, because whatever the vapors, whatever the water is there, it can undergo dehydration by putting the sulfuric acid, and 68% of nitric acid can be concentrated up to 90% pure nitric acid. Chalo, we'll see the properties of the nitric acid, beta, how it will be and what are the important properties of nitric acid. See here. Sir, I will write here itself, beta. So if you want to talk about the properties of nitric acid, so I should say, sir, it is the colorless liquid. It is a colorless liquid, right? But in the lab, whatever the nitric acid we are getting, it contains 68% of the HNO3 by mass. Specific gravity and all are there, no need to bother. But when this nitric acid in the gases state, beta, it exists as a planar molecule. So one more point I will write here. Here, when this HNO3 will be is in the gaseous state, beta, it become a planar molecule. In the gaseous state, right? It has a planar molecule. Like a structure, if you want to draw, beta, HO, then N, then O, and then O, HNO3. Right? Its bond angle is 102, 130. Beta, this is a 130 and this bond angle is 102. Just remember, no need to buy it all. Remember, don't learn it. Right? But in aqueous solution, you know, nitric acid behaves as a strong acid. This HNO3, when you add the aqueous solution on it, means in aqueous medium, this HNO3 will behave as a what? So it behaves as a strong acid. Why would it behave as a strong acid in aqueous medium? Because it has a tendency to form the hydronium ion and nitrate ion. See here, I'll show you. This is a HNO3. But we are putting the water molecule on it. So it has a tendency to provide H plus ion. Sir, water become a what? Hydronium ion. And HNO3 become a what, sir? Nitrate ion. So as it has a tendency to provide H plus ion to the water, act as an acid, but how? Act as a strong acid. Right? Now, HNO3 in aqueous medium act as a strong acid. If the nitric acid is in a concentrated form, beta, it acts as a strong oxidizing agent. And it can attack most of the metal except noble metal, you know, gold, platinum are the noble metal, it cannot. So up to here, write down. The other part I will write one more properties. Take a screenshot instead of writing, beta. Take a screenshot of it. Sir, if the nitric acid is a concentrated nitric acid, it acts as a strong oxidizing agent. That means it oxidizes many metals, but except noble metal. Sir, what are the noble metals are there, beta? Gold and platinum are the noble metal, was not oxidized by the concentrated nitric acid, right, beta? And again, the product which is obtained, see beta, conc nitric acid acts as a strong oxidizing agent. It will oxidizes metals. And what is the product which we are getting due to the oxidation? But it depends upon the concentration of the acid. It depends upon the temperature of the reaction. It depends upon the nature of the material which are undergoing the oxidation. Means now, instead of writing all, just simple I'll write here. Copper is a metal, beta. But if this nitric acid is a dilute, what it gives? And if this nitric acid is a concentrated, what it gives? Very important, beta. Even in NEET, IIT mains, even MSET, everywhere this question was there. Beta, zinc is a metal. Sir, it combining with a nitric acid. If it is a dilute, what it gives? And if it is combining with a nitric acid, sir, and that to be when it is a concentrated, what it gives? See, beta, dilute, concentrated, dilute, and concentrated. Beta, one part is common. It's a salt. CuNO3 taken twice plus water. Common, beta. Salt. CuNO3 taken twice plus water. Beta, salt. ZnNO3 taken twice plus water. Sir, here also ZnNO3 taken twice plus water. But the only thing is that the byproduct which is obtained due to dilute and concentrated, that important. Sir, if the acid is a dilute, beta, dilute, and acid is a concentrated, beta, dilute nitric acid with copper gives rise to NO gas. Please remember, dilute gives rise to NO gas. Concentrated gives rise to NO2 gas. It depends upon the nature, it depends upon the temperature, and it depends upon the concentration of the acid. See beta properly. It is only with the copper I wrote here. Dilute gives NO, concentrated gives NO2. That means concentrated nitric acid with zinc NO2, pakka, no doubt, sir. This is common. If acid is a concentrated, metal always gives NO2. But if the acid is a dilute with copper NO and with zinc beta, it gives rise to laughing gas. What is that? N2O is the laughing gas was obtained. But every year this question was there in exam. Every question, every year. Maximum time I have seen beta this kind of question they are asking. So metal with a dilute and concentrated gives rise to different product. But common, either it is a copper or it is a zinc. And if the acid is a concentrated beta, always what it provide? NO2 gas is provided by it. Right? So take it beta. But in exam one question was there. Copper, zinc, chromium, and aluminium. Which one does not dissolve in the concentrated nitric acid? So what you should say, beta? Chromium and aluminium does not dissolve in concentrated nitric acid. Shall I repeat once again, beta? Chromium and aluminium does not dissolve in the concentrated nitric acid. Why? Due to formation of protective oxide layer on its surface. हाँ sir. But chromium and aluminum do not dissolve in the concentrated nitric acid due to formation of a what? Protective oxide layer on its surface. Means they are passive towards the concentrated nitric acid. Right, beta? Chalo, take a note of this one. Okay. Shall I remove? Take a screenshot. Now, but as it is a strong oxidizing agent, it can oxidize not only metal Sir, it can oxidizes even the non-metal. Sir, what are the non-metal can be oxidizes by? What are the non-metal oxidizes by the concentrated nitric acid, and during their oxidation, how the non-metal can be converted into what are the product formed by it? Let us say, but iodine is a non-metal, carbon is a non-metal, sulfur is a non-metal, phosphorus is a non-metal, and they all are going to combine with a nitric acid. Sir, it acts as an oxidizing agent. But it oxidizes iodine to iodic acid. Sir, HiO3 is called as a what? Right? But it oxidizes carbon to carbon dioxide. It oxidizes sulfur to sulfur. Ha, beta, sulfur is there kada? Oxidizes to sulfur into sulfuric acid. Ha, beta, 0 to plus 6 oxidizes. Phosphorus to phosphoric acid. Actually, H3PO4 it formed. Beta. H3PO3 means phosphorus. H3PO4 means phosphoric acid. But a remaining byproduct is common. What is that? Sir, NO2 plus water. Sir, NO2 plus water. Beta, here also NO2 plus water. And sir, here also beta NO2 plus water. See, act as a strong oxidizing agent, can oxidizes the metal except noble metal, but can oxidizes the non-metal also. They all are what? They all are non-metal. It oxidizes non-metal like iodine to iodic acid, carbon to carbon dioxide, sulfur to sulfuric acid, phosphorus to phosphoric acid. Right? Chalo. Any doubt? But a very important topic is brown ring complex. Right, beta? But this brown ring complex is a very important, and it is actually why it is a test for the nitrate. So I should say test for nitrate ions. If the compound is having nitrate ion, it shows the brown ring complex. But it also have the ability of Fe plus 2 ions. It will reduces your nitrate to nitric oxide. Right, beta? It will reduces Fe plus 2 ion will reduces beta our NO3 minus ion to the NO. So I will show you here how it will be. Suppose nitrate ion present here and brown ring complex may your Fe plus 2 ion is there, right? It is in acidic medium and all. So beta your Fe plus 2 ion will reduces this nitrate ion to NO. Obviously you can check it. Nitrogen की oxidation number 3 into 2, 6 minus 6 become plus 6 minus 1 become plus 5. And here it become a what beta plus 2. So it reduces, Fe plus 2 reduces nitrate ion to nitric oxide. Remaining is same. Plus 2 become a plus 3 and remaining is the water molecule. Right? But whatever the Fe plus 3 which one we are getting here, Fe plus 3 which one we are getting, it is in this way. So the same thing I want to write here Fe. Then I have water molecule taken 6 times. Right? This is a plus 2 ion. Same beta complex form I wrote here. H2 taken system 2 plus. And now the obtained NO is there. Kada beta. These NO. It will combine with this ferrous ion and form the brown ring complex. How you know? Fe. Instead of 6 water, it will have 5 water. Sir, one of the water molecule replaced by the ligand called as a NO. This is a ligand and now it will form here as a Fe plus 2 converted into what you can say beta Fe plus 3 ion plus remaining water molecule. Beta these obtain FeH2 taken 5 times NO 2 plus become 3 plus na beta 2 plus become 3 plus. How it look like it look like a brown ring. So formation of this brown ring complex. But this question so many times they ask even in the IIT, even in the NEET, or we can say in MSET mein they won't ask, but in all the IIT and NEET mein this question was there. What is that? Plus 2. What is the oxidation number of Fe in the brown ring complex? See beta FeH2 taken 6 times 2 plus converted into FeH2 5 times NO 2 plus ion. Right beta? What is the oxidation number of Fe in the brown ring complex? I'll tell you beta. NO become a plus 1 plus 2 become a plus 3. Right beta? NO become a plus 1 plus 2 become a plus 3. Plus 3 means what we have. I will write like that beta. Fe become a X. Water become a 0. NO become a plus 1. Beta equal to plus 2. That X equal to plus 2 minus 1. Beta X equal to plus 1 means the Fe present in this complex is a plus 1 state. Remember, in the brown ring complex, Fe is in the plus 1 state. In brown ring complex, Fe is in the plus 1 state. Why? NO is a ligand having its oxidation number become plus 1 equal to charge. Solid, I got the value. This brown ring complex is a test for the nitrate ion. But in this one, ferrous will reduces the nitrate to nitric oxide. That is plus 2 can be written in the form of complex and NO obtained on combining with it form the brown ring complex. Valence is same beta plus 2 become a plus 2. But in this way, Fe is at which state? That is at the plus 1 state. Right? Chalo, take a screenshot beta, brown ring complex. Now beta we'll see allotropic form of the phosphorus. Allotropic form of phosphorus. Beta it has two allotropic form. One is a white phosphorus and other one is the red phosphorus. Right beta? White phosphorus and red phosphorus. Sir, how it is a translucent waxy solid? According to this one, translucent white waxy solid or waxy solid we can say. But it is a poisonous in nature but insoluble in water. Yeah, but white phosphorus is insoluble in water. It is insoluble in water. But a white phosphorus is insoluble in water but soluble in carbon disulfide. But soluble in carbon disulfide CS2. Sir, the white phosphorus can glows in dark. But it has a property to glows in dark called as a chemiluminescence. Right? Sir, it dissolves in or it reacts with NaOH. Means white phosphorus can be dissolves in NaOH. But when it has a tendency to combine with the NaOH, what it gives? It is dissolving with NaOH and has a tendency to provide the phosphine gas. Means this is a phosphorus on combining with NaOH. NaOH in aqueous form means water molecule should be there. Sir, it liberates the phosphine gas plus plus it will form, it's a salt. What is that? NaH2PO2. Sodium hypophosphate beta. NaH2PO2 is a sodium hypophosphate formed by the reaction of this white phosphorus with a NaOH. Please note down up to here. Compared to white and red beta, white phosphorus is a less stable due to its discrete structure. But what is the discrete structure of white phosphorus? You know, phosphorus, 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 phosphorus. See, beta, it has a bond angle 60° again. But as the bond angle is a 60°, there will be much strain in bond angle. But as there will be much strain in bond angle means obviously it is a less stable. But as it is less stable, that means I can say, sir, it become a more reactive. Please note down beta here. Very important point is one. What is that? Achha, you are unable to see this last line. I'll write here beta. 1 second. I'll write here. So these white phosphorus, what I should say, why it is a less stable due to its a discrete structure. But this discrete structure means I can say its a bond angle is 60°. But a 60° bond angle means it has much strain in bond angle. But a much strain in bond angle means it is obviously more reactive. Obviously, but a less stable means the compound should become more reactive. Hence, it become a more reactive. Right? It is about the white phosphorus. Now, second part. What is that? Red phosphorus. How it is obtained means simple, I'll say. But a white phosphorus, when it is heated, it will be converted into red phosphorus. Yeah, temperature 573 Kelvin, some inert atmosphere and all. Right. All these things is known. Just directly we'll see the differences of that one better. Differences. But when this red phosphorus is heated is under high pressure, it gives a series of black phosphorus, right? Chalo. How it look like? So it is a waxy solid. So I should say it red phosphorus, if you want to see, it has a iron gray luster. It is a iron gray luster, red phosphorus. But it is a discrete molecule means it is a polymeric form. Correct? Yeah. It is a poisonous means it is a non-poisonous. So I should write one more point. Sir, it is a odorless and non-poisonous. Yeah, but it is odorless as well as a non-poisonous and insoluble in water as well as in CS2. See, beta, it is insoluble in water, kada? So I should say, sir, this one is insoluble in water as well as in carbon disulfide, beta, as well as in carbon disulfide, insoluble in CS2, right? Sir, it glows in dark, so it does not glows in dark. So differences of this one, but it has a polymeric form. but it has a polymeric form. So more stable and white phosphorus become less stable. So white phosphorus is more reactive than that of less phosphorus. So just I wrote here, beta, white phosphorus and red phosphorus, it has a discrete structure, it has a polymeric structure. Because of that, it is more stable, less reactive. White phosphorus, because of much strain in the bond angle, less stable, become more reactive. More stable, less reactive, less stable, more reactive. Right? Chalo, take a screenshot, beta. Now we will see about the another compound of phosphorus, that is phosphine. We'll see another compound, that is a phosphine.